Hi, everyone. Thanks for joining us today at ProQuality Community. My name is Oksana Belarus. I'll be your host today. And also, quick shout out to our tech moderator, Timur, who will be responsible for our tech stack during the session. And today, we're talking about big data, big drama, stories about migration testing. I'm excited to welcome Dmytro Sobko, quality architect with deep experience and not only with testing. So great to have you here at ProQuality Community. Hi.
Hello, everyone. Thank you.
And dear audience, please feel free to drop your questions on the YouTube chat on or via community platform. We'll cover them in the Q&A part. So let's start with a quick question. And Dima, do you believe there is such thing as a safe data migration, or is it always uncontrolled or controlled house?
Very interesting question. Thank you. I would say it rather controlled house because in any case we cannot guarantee that everything is safe and that we controlled everything. In most of the cases, there are some like hidden gems or stuff like this. And the idea of migration testing is to eliminate such kind of risks and increase, actually, quality of migration, I would say.
Okay, thank you for your answer. And so let's get started. I will pass the floor to you.
Thank you for such an intro. So let's start, guys. Today we will talk about big data, big drama. My name is Dmytro Sobko. I'm quality architect. Currently, I'm in Romania. So I have more than 14 years of experience, various experience. I started as manual QA and had during my career I had a lot of different projects. In some of them I participated as a quality assurance lead. And today I want to talk about projects from my again own experience. So about data migration. So this is the real world examples, and these stories happened before the AI boom. Yeah, so few years ago, some of them like about 5 years ago, and the testing process, was a little bit different back in the times. But don't worry, actually, we will talk about AI at the end for sure. So let's get started. So our agenda for today, first we will talk about data migration. After that, three real examples of data migration. So first we will talk about Oracle to Azure migration. After that, Hadoop to AWS and Netezza to GCP. So all three major cloud providers. After that, we will talk about to sum up all the things, we will talk about data migration testing essentials, and of course, sixth chapter it will be about AI. So data migration. I like this picture very much because it's actually visually presents all the things happened in such kind of projects. So first, we have data, so it's unstructured, it's like Lego bricks, and that's true. We can sort it, so when it is sorted, it becomes more or less usable, especially when we filter out some broken things, broken stuff, actually broken data. Once it becomes arranged, so it is actually usable in all kind of transformations, calculations, presentations, etc. So we arrange data, we can present it visually, and it will be useful for some reports, metrics, presentations, and of course we can even explain it with a story, and we can, for example, check by the data why some of our customers migrated from one plan, in subscription plan, to another one, let's say, or why we have so many orders in some kind of on Black Friday, let's say. And again, what I just described, it was actionable, useful data. Few things about data migration approaches. So still some enterprises uses on-prem infrastructure, and they plan definitely or will plan to migrate to cloud. So some drivers are enterprise cloud expansion, multi-cloud storages, and data platform modernization. For challenges and risk, the main risk is security, and actual challenge security and compliance constraints, especially when we talk about HIPAA and GDPR and stuff like this. This should be actually tested very carefully, verified, and migrated actually carefully. So complexity, data migration complexity, also a huge challenge, because for some of the systems, especially very old, it's pretty hard to migrate a huge amount of data to the new cloud providers. And operational downtime risks for some of the systems. We will talk about one example later during this presentation. There is no way to turn off and turn on production even for 1 second. So the idea is to have production running 100% of time, so no downtime at all. And migration technologies, they are evolving very fast. And again, today is AI. Some kind of tooling have already pre-built AI capabilities. So infrastructure as a code is a must right now. And actually testing and reliability engineering also changed. For QA process, you may think that for such kind of projects, like data migration projects, it is a little bit different comparing to usual one where we have API, like for example, backend written on some kind of, let's say, microservice backend, and front end, and let's say mobile applications. For past data migrations, we still need to have pretty much the same approach. So we definitely need to identify functional requirements and non-functional requirements, and define customer expectations and wishes, for example, when we just start such kind of projects. Test strategy, again, in majority of cases, it's a must. Test automation framework. Some kind of projects, I would say, can omit test automation, but it's a rare case. From my own experience, still with test automation, it's much faster. We gain more confidence in data quality, especially, and it's actually reasonable and useful to have test automation. It will help a lot. For some kind of projects, performance test automation also is a must, because customer has very strict performance requirements. That's why we need actually to test it to meet such kind of expectations. Once we establish the process, we define definition of done, definition of readiness, and so that we can successfully release all the things and go further. Some pretty obvious stuff, but still it is in many cases underestimated. Manual data migration, it's pretty hard thing, and I would say it's that. And smart data migration, it is funny, it's smooth move, and bigger future. So let's move to the first real world example, Oracle to Azure migration. What we had here, the project was aimed to migrate all Hybris-like system to the cloud, to the Azure, and we split old monolith applications into a bunch of microservices. Also, we migrated a bunch of the data from Oracle to Azure. And the most complex thing was that we need to have both systems work in parallel, and that's why we streamed transaction data, actually implemented replication between old system and new system. Moreover, the new system and old system looked identical. So, and the idea was that, for example, customer log into our portal, start actually creating order, let's say, order something. After that, he successfully paid, and when he checked his previous orders, for example, previous orders was implemented on the old system, but not implemented still in the new system. And the idea was that orders were replicated from new one to the old one, and on the old UI, the customer should check and should be able to check all his orders. So the data replication was our cure here. So we performed action on microservice, like create order. This action was replicated and saved in the Hybris DB, the old one, and vice versa. Some, for example, delete order functionality was only on the old system, and once the customer deleted order on the old system, we should delete it from the new system as well. So some scenarios to consider. Some messages duplication, so network errors, incorrect data, messages ordering, interrupt and continue. Customers press back buttons and forward button, etc., etc. It was pretty challenging, but still we managed to do this. And here's some kind of pseudocode how to test it. So let's say in our test automation framework, we manually updated data in Oracle. So inserted some kind of new customer data. After that, we verified that event appeared in Kafka queue. because all the replication was implemented via Kafka. So we check the queue again, right from the test automation framework, and check the event. And after that, we verified the Cosmos DB. So some kind of end-to-end checks, assertions. We verify the Cosmos DB and check that new record appeared in Cosmos DB with the same data we inserted on the step one. So that's how it looked like. Again, we checked all the things. We checked the duplication, network failures, some kind of dead letter queues, etc., etc. Looked pretty, like, let's say, scary at the very beginning when it just started, but after all, it was manageable. Let's move to the second story. It's Hadoop to AWS migration. Here we had a really huge amount of data, more than 5 petabytes. And there were a lot of data transformation stages. So fixed time for migration because customer did not want to buy new memory, new hard disk for on-prem servers, and we had each day around 1 terabyte of new data. So it was again pretty interesting and pretty tough project. The main challenges we faced there that verified that we had more than 10,000 daily files each day, and like each new day, like for today, we would say we also will receive 10,000 files. So data lake has a replica in another AWS region. So we had multi-region setup, US East and US West. And for such some kind of test scenarios, we had test data files that are more than 50 megabytes. So pretty huge one. And the idea was to compare them in our test automation framework. So how we managed to do this? So first, we introduced so-called hash-based verification. Instead of comparing each file from source system with the same migrated files in target system, because it would cost us a huge amount of money and huge amount of compute resources. We introduced hash-based verification, where we calculated the hash of file from on-prem. We calculated the hash from that file on AWS and compared hashes. If everything is okay, we say that the file migrated successfully. If something goes wrong, hash are not identical, we dive deep into the details. It was done for each day for 25 years, I would say. And also we selected a random day during a week. So let's say we migrate 1 week of files and we select that Wednesday is our random day for this week. And for this day, we compared each file row by row to gain even more confidence. This is how it looked like in our pseudocode again. So we calculate hash on-prem market file. So like pretty usual Java-like code. So just hashing. After that, we verified that packet files transferred to S3 bucket in our case. And after that, calculate hash of the new file on the S3 bucket and assert that they are equal. Once we done with this, the idea was to check the transformation logic inside So again, as I mentioned previously, we had 5 transformation stages. So when we migrated raw data, it was not the end of the story. We need to also check the transformation logic we migrated. And here we had pretty huge test data files, about 50 megabytes. When we started to verify them, here it is mentioned like an anti-pattern, but we of course started with such kind of things. We try to assert that they are equal. And we faced out of memory error because they are pretty huge. And we started to increase buffer size. We used another runner. We tried to increase memory in runner, but that also didn't help. And we ended up with introducing Spark inside our test automation framework. So again, sounds pretty strange, I would say, but the idea was unusual, let's say, but it was absolutely great experience. We managed to compare such kind of files pretty easily. So introducing Spark, it's like one or few dependencies in a Gradle file. And after that, we could use such kind of code like introduced here. So compare data in distributed Spark job. Inside test, we started small Spark job. This job compared, read 2 files, compared them, and output was the result of comparison. Again, pretty unusual thing, but it worked very fine in our case. Let's move to another story. Netezza to GCP migration. Here we had, again, cloud transformation journey, but from Netezza to GCP. Here, customer had a lot of very, I would say, complex, very beautiful and interesting Tableau reports. Tableau reports, it's a visualization of different data. And let's say the idea was to keep the reports the same, but migrate just the data behind these reports from old system to the new one. So no data quality checks was for on-prem solution. We didn't know whether this data is correct at all or not. So no clear requirements. First, we thought that if we migrate data as is, everything will be okay because we will just repoint analytics platform from one source to the new, from old source to the new one, and it will be fine. Moving forward, it did not help us. After that, we thought that we can and we must modify reports as well, because it's impossible. It was impossible in that case to migrate data as is from Netezza to BigQuery, because structures of the systems and structure of the tables, column types was different, and it is what it is. So main challenges we faced. We had really huge tables, like more than 1 million rows and more than 500 columns. It was also huge amount of streaming data. And again, as I mentioned previously, Tableau reports should be absolutely identical, because Tableau reports were used for top management reporting, and they already get used to such kind of visualizations, and they insist that all the stuff related to reporting should remain the same. So one of the challenges, row-by-row table comparison. If you would think and try to identify some core concepts, how to compare such a huge tables, like let's say 2 million rows, 500 columns, SQL-like data. And we need to identify some gaps if possible. I would say that personally, I would say that I would create some Spark jobs, stuff like this to insert into memory, and after that somehow to transform this data and try to compare with equals or stuff like this. But the idea we used was pretty simpler, I would say, and pretty obvious one. We compared it row by row, and it was again a good solution. In our case, it was pretty fast and absolutely reliable. So what we did here, we created a new comparison table, and in that table we inserted 0 or 1s. If cell is identical, data in the cell is identical between new table and old one, we put 0. If there is diff, we put 1, let's say, and joining two tables and compared. And after that, we were able to select just once from that comparison table. It was our mismatch count, and we realized if everything was migrated successfully. So pretty interesting experience. Again, some of us had doubts regarding this, but as time showed, it was okay and it was useful. Another idea is again to use hash-based table comparison for some of the tables. Actually, the not so huge ones, we used hash-based verification of them. So we created hash from the row, from the particular row, and actually all columns inside this row. And as you might see here in this pseudocode, we compared hashes and with full outer join checked if everything was okay. So let's move on to sum up these three stories about data migration. As you may notice, three of them, they were pretty different. We faced, let's say, few challenges. We solved them in different ways. But what you should remember, test won't fail only if you don't write tests at all. So it's absolutely normal situation when we have read let's say, failed tests during our migration projects. It shows that they are doing what they should do. They faced that we have some problems in our logic, for example, or we used not the right source or stuff like this. And it's, let me repeat myself, it's absolutely normal situations. To sum up some validation types, there are four main of them, four core validation types. In such kind of testing, first, accuracy. It verifies that, for example, if we have in one cell number 100, we verify that it was migrated successfully, and in the same cell we have 100. Completeness. We verify that when we do not miss some kind of rows during migration, or even tables, I would say, or in another case, files, when we have data inside Parquet files. Business rule validations. For some of the tables or for some of the data, during migration, we do not migrate as is. So one table cannot be pointed to the same table in the target cloud. In this case, we need to check transformations, mappings, I would say, and calculations. It is a pretty usual thing when we migrate two tables and we remap it into one. And metadata validations. For example, let's say we have Parquet files, maximum size is 1 megabyte per file. So in this case, we definitely need to check that we do not have larger files, or we have in some kind of tables that should be migrated as is, we have indexes. Let's say they should remain the same. It could be the situation. We also need to verify this. So core validation types, 4 of them. Another interesting question is about test data. So test on real data. In some of the cases, looks unaffordable at all, because there's a huge amount of different columns, file types, some huge hashes or huge numeric values or huge even blob data where it's you don't know how to use it. But it verifies actual migrated data sets. So we definitely on production, we need to have this. No way to do not test this on production. So it helps us to detect schema and integration issues pretty easily, because once we used the real schemas, real formats of files, it reveals that we have some gaps in our logic. And on another part, mocked stub testing, looks like we can create a different mocks, let's say, and use them in test automation framework, and it will be easily to modify them, to compare them. They will be more lightweight and ideal for transformation and edge case coverage. And the idea is that both of these approaches are true, and both of these approaches should be used in real projects. So they serve for different things. So for these mocks and stubs, we can use them in test automation. So they can give us fast feedback. Some complex logic is easily be validated with mock stubs than with real data. And we can easily create some edge cases with these mock stubs. On the other hand, real data. So for end-to-end verification, definitely we need to use real data. For business confidence, we cannot say our customers that everything is done, everything is working as expected, once we have not tried this with real data. And the last point, detection of hidden data issues. For such kind of projects, on big data projects especially, there is always room for hidden gems. For some rules that were undocumented, and for some like small tables with newly created data that look like they are obsolete, but they are not obsolete. And after that, it becomes clear that this small table is used in core logics, let's say, and we need to transform it as well. So just to sum up, why combine both mocks and stub validate transformation logic early, real data sets for final tests and for real production ready tests, and combine strategy, all of the things. And the last chapter of our today's talk, how AI can help. Things I've described. Actually, I think you already aware of this. AI can be used in all of the stages I just described. So for data quality checks, for automated validations, we can create some kind of agents to compare billions of records and find some anomalies. For performance and cost optimizations, definitely we can use AI to help us write more optimized queries. So to queries, actually ETL jobs, transformation logic, optimized transformation logic to make it faster, to make it use less resources, and of course, in terms of quality assurance and testing, we can use AI for test automation and CI/CD. For such kind of projects where we have automation tests that compare two files, like no interactions with UI, no interactions with like mobile apps or even API. So tests look like just have one source file. For example, run Spark job, one target file, and you need to, inside test, you need to compare them. AI agents that create automation tests work perfectly for such kind of things. Again, very funny meme. I like it because it actually shows the very common questions we faced when we delivered some kind of data migration or data transformations in the last, let's say, stages of the projects, when everything is done and customer checks the data and check, for example, reports and ask very simple questions. Why I see, for example, 100 in this column? I need to have 1000 let's say, customers in this column? And the answer is, I don't know, or we don't know, because data migration, the main challenges of this data migration projects is some undocumented things, undocumented stuff, broken data, some gaps in transformation logic. And after all, when everything looked pretty good and pretty obvious, we definitely say some anomalies and started deep and long investigation of how it looked like in the early stages, why we have this such kind of numbers. The last data stages, let's say, yeah. And yeah, this is part of our work as quality assurance as well. And last but not the least, hidden tags of AI-assisted development. Let's say we introduced AI in all of the stages. AI helped us with data creation. AI helped us with test automation. AI helped us to verify a huge number of tables, data files, etc., etc. But what we should keep in mind, first of all, faster coding not equals to faster delivery. So AI significantly increases code. No, I mean number of code lines and accelerates code generations, but delivery could be tough here. So traditional metrics. Let's say if we talk about AI native delivery, so lines of code or lines of some test automation tests, it doesn't reflect real business impact. Hidden tags, because we have more pull requests to review, we have more regression testing, and AI-generated code can increase volume faster than team can verify its quality. And just to sum up this AI adoption slide, AI is not automatically a productivity multiplier. You should be aware about this, but still it is necessary, I would say, because to use AI right now in such kind of project, because it gives us much more pros than cons. Thank you very much. That was all from my side.
Thank you for this talk. Thanks for sharing real life examples and even parts of the code. It always helps to understand the topic more clearly. And dear audience, if you enjoyed the session, please scan QR code to rate our event and award a badge to our speaker and moderators. We'd really appreciate your feedback. And it's not so easy to run an event in the morning and stay energetic, right? And now let's move on to the Q&A session. So the first question, how did you make sure that hash code covers all data included in the Parquet file and metadata as well, if there were any?
It was a special library to how to say, to hash, to calculate hash of the files. We used Murmur hash library, and it was industry standard for such kind of things, and this hash covered not all, but as much as possible data included in the packet files. Yeah, and as I mentioned, to gain more confidence, we used to have to compare deeply one random file for one random day from each weak folder. So, and combination of these approaches helped us to have enough confidence in data quality, in terms of data quality, I would say.
Okay, thank you for your answer. And the next question, have you encountered partial data loss during migration, and how did you resolve such issues?
Of course, I would say so. Some of the jobs may be interrupted during data migration. So it is also always room for some network failures and stuff like this, especially if we migrate some data between, let's say, Europe and USA. And the idea was to either totally delete, let's say, corrupted day folder and start from the beginning. So just re-migrate the particular folder from the scratch. Either check what was migrated successfully. So, for example, we have the migration job that should migrate like 5 tables. We check that one table was migrated successfully, one partially, and 3 were skipped. So we keep the one successfully migrated as is, slightly modify or change the parameters of the migration job to start from the second table. And here it is. We need to migrate the rest, I would say.
It's not so bad result, right?
Yeah. Yes.
Okay, and the next question. Yeah, from your experience across various migration, what's the one testing area teams tend to underestimate the most, but that later causes the biggest issues?
Biggest issue. Very interesting question. So, the biggest here we had the situation when, after all, everything looked absolutely fine. For example, we migrate SQL tables, and rows looked pretty much identical. So just a few transformations. Data in the cells, again, looked identical. So we had number 1000 in the source table, 1000 in the target table. But what we have missed here is some business logic that were not transformed during the time where we transform data. So that's always the root cause of such kind of failures. So we put all the attentions on data quality, but we missed data semantic, I would say. So in the new system, in the migrated system, some of the columns should be used different way. and that's the part. Actually, it's the biggest issue, I would say, answering to this question.
Mm-hmm. Okay, thank you for all details. And the next question, what are the most common and widespread problems in all of the listed types of migration? Interesting question.
Yes, because they were so different. I mean, these three projects. Most common spread. I would say, I will repeat myself. It's I like this phrase very much. It's hidden gems. So when you suddenly realize that we miss some kind of things, so we missed some of undocumented logic. So it was somewhere on conference, but customer hadn't had a chance to talk to us about this, or subject matter expert already left the company, and we realized that we miss something. In all of this, yeah, three, let's say, transformations, it was a moment when you think that everything is done. We are totally fine, so we just need to like final check and we are ready for production. And somehow you realize, after all, that it is not working as expected. And we started these deep investigations, checking the documentation, ask customer, and blah blah blah. And after that, yeah, it was some kind of hidden gem with undocumented things or broken data that actually is not broken, but it just should be transformed differently, stuff like this.
Okay, thank you for your answer. And the last question, as I think. Uh, when timelines are tight, how do you decide not to test immigration scenarios without significantly increasing risks?
Here we should use risk-based approach, I would say. So some critical and crucial business scenarios should be covered fully, no matter what timelines we have, they are tight or not. So some core things should be covered no matter what. If we identify that some, let's say, historical data is not used heavily right now in some reports or stuff like this, we can let's say have hash-based verifications for such kind of tables instead of fully row by row comparison, and we can move this kind of things to the second phase. So short answer is risk-based approach.
Mm-hmm. Okay. And we have a long question, but we tried to make it shorter. But I will read the whole sentence. So you are migrating a 120 TB distributed data warehouse from Hadoop ecosystem and OCR with late schema evaluation to a cloud native lakehouse object storage and plus Delta schema enforcement exit transition. During parallel migration, both systems must remain writable for 6 weeks. Historical data 10 years contains under document schema drifts, silent truncation, time zone inconsistencies, and non indent bond downstream aggregation. How would you design an end-to-end migration testing strategy that can prove semantic equivalence of business critical analytics, detect data corruption introduced by schema enforcement and compaction, and isolate root causes when appear without reprocessing the full dataset repeatedly or blocking production writes? That's the full sentence.
Yes,
Very long question.
very long, very interesting. I would say, to be concise here, I would say that we need to introduce and we need to test here from the very beginning, and we need to introduce, if not in place, unit and integration tests. So for all the ETL parts, it actually don't matter on which language it is written. For example, in Scala, we can introduce integration tests and check the transformation logics in isolation with mock data. This will help us to verify this small chunks of logic, and after that, on the new, again, if I remember, there are several transformation stages. On the each of transformation stages, we create some kind of verification tools, some kind of tests, verification tools that would compare just transformation logic between stage A and stage B. And this will also reduce the scope of testing, and this will reduce the possible root cause of data inconsistency, if any. So short answer: introduce multi-layer testing types, let's say.
Okay, guys, our time is counting down. And thanks for being with us today. And Dima, thanks for sharing your experience with data migration. I'm sure our audience picked up some useful ideas they can apply to their work. We'll add the presentation deck to our talk page along with this recording after the event. And we'll also send a feedback form by email within an hour. And please feel free to add your comments so that we can make our events more interesting for you. Also, please note that we started call for speakers for our upcoming conference that will be in autumn. Take an eye on this and join our event as well. That's all for today. Stay tuned, join ProQuality community on YouTube, and have a great day. Bye.
Thank you very much. Bye-bye.